Today we will learn about the symmetry in regular polygons. Have you seen the half-sliced apple carefully? It looks like this. Can you tell what is special in this? Think. Exactly. By drawing a vertical line going through from the middle of it, we see that the parts on both the sides of this line looks exactly like the other half. They are mirror reflections of each other. Such a shape is called a symmetric figure. Let us understand symmetry in more detail. Symmetry is not a new concept for you. In your daily life, you have seen many things which are symmetric, such as flowers, carom board, a leaf, scissors, and many more. Now you see this polygon. If we draw a line from its center in this way, we will get two parts of this polygon, right side and left side. Here, the left side is exactly as the right side. If we keep the right part on the left part by folding the picture along with this line, then we see that the two parts cover each other completely. In such a situation, we say that the shape is symmetric. When one half of the figure covers the other half completely, when folded along a line, we say that the shape has line symmetry. Such a line is known as a line of symmetry. Line symmetry is closely related to mirror reflection. If we place a mirror along this symmetrical line in the same figure, we see that the left part of the figure reflected in the mirror exactly matches the right part of the figure. What do you understand by this? Think. Absolutely right. From this, we can understand that in terms of linear symmetry, one half of the shape is a mirror image of the other half. In the context of linear symmetry, we can say that the mirror line is a symmetric line. That is, with the help of a mirror line in a figure, we can find the symmetrical line. Keep in mind, in mirror reflection, there is a left-right change in the orientations of the shape, which we call lateral inversion. This means that the right part of the shape becomes the left part of the image, and the left part of the shape becomes the right part of the image. Now, can you tell which line is a symmetric line in this shape? Think. Yes, you are right. If we look at the line N, this line divides the shape into two such parts that one half of the shape becomes a mirror image of the other half. Therefore, we can consider the line N as a mirror line. Since the mirror line is a symmetric line in terms of linear symmetry, N is also a symmetric line. But if we talk about the line M, we do not get two such parts which are mirror reflections of each other by placing mirrors along it. In this way, the line M cannot be a mirror line as well as a symmetric line. If we draw a horizontal line like this, in this figure, the line L also divides the shape into two parts that are mirror reflections of each other. This allows us to know that a shape can have more than one symmetric line. Especially when we talk about regular polygons, we can see more than one symmetric line in them. A regular polygon is said to be regular if all its sides are of equal length and all its angles are of equal measure. Just like an equilateral triangle is a regular polygon. Because all its three sides are equal and all three angles are equal, each measure of 60 degrees. Can you tell how many symmetrical lines this triangle can have? Think. We can draw three symmetrical lines exactly like this. Similarly, the square is also a regular polygon and thus four symmetrical lines can be drawn. Similarly, we can draw 5 symmetrical lines in the regular pentagon, 6 symmetrical lines in a regular hexagon, and 7 symmetrical lines in the regular heptagon. Can you understand this pattern and give us a rule so that we can find out how many symmetrical lines there are in an regular polygon? Think. Absolutely right. Each regular polygon has as many symmetrical lines as its sides. So how many symmetrical lines can be drawn in an regular octagon? Think. Exactly. 8 symmetrical lines can be drawn in it. So today we learned symmetry in regular polygons. We will understand it better by discussing some examples in the next video. Today we will see some examples related to the lines of symmetry of regular polygons. How many symmetrical lines are there in the figures shown below? We know that a mirror line divides the shape into two parts that are exactly like each other, as if they are mirror reflections of each other. In the context of line symmetry, the mirror line can be considered as a symmetric line. That is, we can say that the symmetrical line divides the shape into two parts, which are mirror reflections of each other. With this understanding, we can find the number of symmetrical lines in the given figures. If we draw a vertical line in the first figure, then this line divides the first figure in two parts, which are mirror reflection of each other. Therefore, we can call this line a symmetric line. Similarly, if we draw a horizontal line in the first shape in this way, then this line divides the shape into two parts, which are not mirror reflections of each other. Therefore, the horizontal line is not a symmetric line. Now, we will draw a slanted line like this on the shape. This line divides figure 1 into two parts that are not reflections of each other. Therefore, this line is not a symmetric line. Similarly, you stop the video and make this shape on paper and find out how many symmetrical lines it can contain. You will know that there is only one symmetrical line in this shape. Now, let's talk about figure 2. In figure 2, we will draw a vertical line going from the center. The vertical line divides the shape into two parts that are mirror reflections of each other. That is, the vertical line is a symmetric line. Similarly, we can draw one horizontal line going through the middle of the figure and two oblique lines showing two more lines going through the two diagonals of the shape in this way. Each of these lines divides the figure into two parts that are mirror reflections of each other. That is, all these are also symmetrical lines. Apart from these, no such line can be drawn in figure 2, from which we get two such parts of the figure which are mirror reflections of each other. Therefore, we can say that figure 2 has 4 symmetric lines. Example 2. Complete the shape shown in the figure in such a way that the shape is symmetrical along with the symmetric lines shown. We know that the symmetrical line divides the shape into two parts that are mirror reflections of each other. With this understanding, We will consider the line M and line N as mirror lines and make a reflection of the part represented in the figure, from which we will get a complete shape. We will do this with the help of the square shown. Let us consider the horizontal line N as a mirror line and draw the image. This is how we can do it. Now we will consider the vertical line M as a mirror line and draw the reflection of the left side to the right of the vertical line. For this, we have to keep both these parts in mind. Keeping these in mind, we can draw mirror image in this way. With this, we have completed the figure. Here the shape is symmetrical along both vertical and horizontal lines, thereby verifying that our answer is correct. Today we saw some examples related to symmetrical lines of regular polygons. In the next video, we will see some common mistakes related to the lines of symmetry of regular polygons. Polygons. Today, we will see some common mistakes related to the lines of symmetry of regular polygons. Mistake 1. If some children are asked how many lines of symmetry are there in the rectangle, then the children answer 4. They think that vertical and horizontal line of symmetry can be drawn in a rectangle as well as line of symmetry along diagonals. But this is incorrect. Let us clear this misconception by doing an activity. Take a paper and cut a rectangle from it. Or, if you have a rectangular paper, take it. Now fold this rectangular paper along one of the diagonals. Do you get parts that completely overlap each other? Try it by doing the activity. You will know that by folding the rectangular paper along one diagonal, you do not get two parts which overlap each other completely. Therefore, a line drawn along a diagonal in a rectangle is not a line of symmetry. It is a matter of course that the crease on the rectangle obtained by folding the rectangle along the midpoint of the width or by folding the rectangle along the midpoint of the length divides the rectangle into two mutually equal parts. A rectangle can have only two lines of symmetry, one passing through the center along the length and one passing through the center along the width. Mistake 2. If the children are asked how many lines of symmetry are there in the following figures, then the children see that both figure 1 and figure 2 have 4 sides. So they tell only on the basis of the sides that both the figures have 4 lines of symmetry. But this is incorrect. If a shape is a regular polygon only, then the number of lines of symmetry will be equal to the number of sides of the polygon, otherwise not. If we look at the first figure here, a square is shown which is a regular polygon. So we can say that there are 4 sides of a square, so 4 lines of symmetry can be drawn in it. If we talk about the second shape, then it shows a trapezium, which is not a regular polygon. Therefore, it is wrong to find the number of lines of symmetry in figure 2 based on the sides. Only one line of symmetry can be drawn in this figure, which is as follows. Mistake 3. Some children draw lines of symmetry correctly in a shape, but when they count them, they count each line twice by mistake. Like here, they get 12 lines of symmetry, where actually lines of symmetry are 6. In this way, they get twice the number of lines of symmetry than the actual number. Similarly, some children stop counting on the line from which they start counting inadvertently. In this way, they count a line twice. This makes them think that the number of lines of symmetry in the given figure is 7. But it is also incorrect. In order to count correctly, we should keep in mind that from which line we have to count. This will get the count right. So today, we saw some common mistakes related to the lines of symmetry of regular polygons.